Welcome to Praveen Patil, College of Diploma Engineering and Technology. Myself Raj Ghiware, working as a lecturer in Mechanical Department. We are looking on the subject Theory of Machine. We have started with chapter number 3, Camp and Follower. In this, we have discussed on what is a camp and follower. We have seen the motions of camp and follower. Also, we have discussed about various types of follower along with the terminology of the camp. Now we will be discussing on the types of motion of the follower. So here, when the cam rotates at a uniform angular velocity, the follower may have the following motion, which are as follows. The first one, which we say it as a uniform velocity or uniform motion. Second one, which we represent as SHM, means simple harmonic motion. The third is UA and R, that is uniform acceleration and retardation. The last is cycloidal motion. So we will be discussing on displacement, velocity and acceleration diagram when the follower moves with uniform velocity. Here in this we are able to see the displacement diagram when the cam moves with uniform velocity. Since the follower moves with uniform velocity during its rise and return stroke, so we are able to see this is the rise. Let me highlight this part. So this is the rise, which is performing a rise, means rise movement of the follower, and this is the return stroke of the follower. And dwell is nothing but the idle stage where the follower is not moving upward, either in upward lifting up or lifting down. It is a dwell, means in a same position. Now apart from this, since the follower moves with uniform velocity during its rise and return stroke, therefore its displacement curve is a straight line, which we are able to see. It's like this. It is a straight line like this one. Okay, this part. Now here in this, if we, in order to construct a displacement diagram, what we have to do is we have to choose a scale for construction of displacement diagram, say 1 is to 20 degree. Now what we are going to do is we will be drawing a straight line, let's say 18 centimeter, this as a straight line. I will just clear out all this. So let's see this AE as a straight line which will be 18 centimeter, as that is theta equals to 360 degree. So what we are going to do is we will be dividing this all the line corresponding to outstroke and return stroke. So based on whatever the angle of outstroke, okay, based on whatever the angle of outstroke and return stroke, that we will be dividing this part. That means here we will be dividing this AB for the rise, BC for the dwell, CD for the dwell, and DE also for the dwell. So when we divide this part, so the number of division on the point which we are able to see from the figure. Now here we will represent the rise of the outstroke, dwell and return stroke in this displacement diagram. Now regarding uniform velocity, so this is the diagram for which we are corresponding for the uniform velocity. Coming towards the next, that is motion of follower with simple harmonic motion. Now this is the displacement diagram of the follower when it moves with simple harmonic motion. So here also we have to follow the method of drawing the displacement diagram. That is, first one, we have to choose a scale. We have to draw a line according to the scale, that is this line according to the scale. So if we take 1 centimeter equals to 20 degree, say 18 centimeter will be for 360 degree. So what we are going to do is we will divide the line into number of strokes. So this is the part of the line with on the outstroke, return stroke. Okay. Now coming towards the next, we draw a vertical line. We have to draw a vertical line to give a lift of a stroke. Okay, this is the displacement lift of the stroke. We have to complete the rectangle, so like this way we will be completing the rectangle lift of the stroke. This height will be depending on the how much is the lift of the stroke. So after that we have to draw a semicircle which takes lift as a diameter. So this is a semicircle which has been drawn over here. Okay, this part of semicircle. Now, once we draw the semicircle, we have to divide the semicircle into equal number of parts. So, we are dividing this into equal number of parts like this way. And once we divide the semicircle into equal number of parts, what we are going to do next is we will trace the point further. So in simple terms, we have divided this part, that is from this point to this point, as well as we have divided from this point like this way. So all these divisions are represented in this area. So here how this curve is generated is, once we make a division, whatever intersect point of this vertical line and horizontal line coming, that intersect points we will be taking down. And once again, when we get all the intersect point in rise as well as in return strokes, this is the rise stroke and this is the return stroke. So we will be joining all these points. So when we join all these points, we will get a curvature like this. So this is nothing but the displacement diagram, which is a velocity and acceleration diagram for the follower moving with SHM, that is simple harmonic motion. Now let's see the next one, that is motion of follower with uniform acceleration and retardation. So in this we have taken various degrees. Okay, once again here also we will choose a scale, we will draw a line according to the scale, that is we will draw this line according to the scale. If we are taking 1 centimeter equals to 20 degree, then the total is 18 centimeter, that is for 360 degree. So here 50 mm is the stroke. See here, this part vertical line represent lift or a stroke of the follower. Now once we do this, we will create a rectangular block like this way, and then based on the angles, that is how much angle, what here 120 degree is the angle for the, this 120 degree is the angle for the outstroke, then there is a 60 degree of dwell, that is the follower is not moving, lifting or moving down, and this 90 degree, this part 90 degree is for the return stroke, and then remaining 90 degree is for the dwell period. So we will mark this point, that is A, B, O dash, A, B dash and V points on this, and we will be drawing the line, we will extend this line upward, so that we will be creating a box like this for outstroke, for return stroke and for the dwell. So once we finish this, what we are going to do after this is we will divide this AB into equal number of divisions. So we have made 8 divisions. So once we made a division, we will draw a vertical line upward like this way, and then when we finish this part, we will be joining a line from this point to this point. Same way here also we will make a divisions and divisions like this. So once we complete this part, whatever intersect point which we are getting from horizontal and vertical line, that points we will mark it. So here these are the points which we have marked, that is A, B, C, D, E, F, G, H and J. So we will join all this line to get a curvature like this. So same procedure which we have to follow for return stroke, and here also we will get this part. So this is all about the displacement diagram for the motion of the follower with uniform acceleration and retardation. So that's all for today. We will stop here and we will meet in the next part of the video. Thank you.